This is the 7.2 mini lesson. Each representation shows a balance. What will balance one rectangle in each problem? Adjustments can be made in each pan as long as the balance is maintained. Describe your strategy. So I think the first thing I'm going to look at is I could remove 6 of the little squares from each side to maintain balance. So if I take these 6 off and these 6 off, it would still maintain its balance. Now I look and I want to know what one rectangle is. Well, I can match this up. One rectangle would be 3 of these squares. So I'm really dividing the squares by 3 to see how many squares represent each rectangle. So one rectangle is equal to 3 little squares. Okay, I can do the same thing here. Strategy, I'm going to remove 3 of the squares from both sides. So I'll take those 3 off. I'm going to also remove 2 of the rectangles from both sides. So these are gone and these are gone. Now that means I have 3 rectangles and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 squares, 3 rectangles. So that means one rectangle, if I divide the squares by 3, one rectangle equals 4 squares. Okay, so one more time. Strategy, I'm going to remove 2 squares from both sides. I'm going to remove 1 rectangle from both sides. So here, this one's really easy. One rectangle is 3 squares. One rectangle equals 3 of the squares. So if you need to pause this to get all this written in, that's fine. But what we decided to do is that to maintain balance, if we subtract a quantity from one side, so when I removed from one side, I would have to remove the same quantity from the other side. If I added something to this side, I'd have to add the same thing to this side to maintain the balance. If I multiplied this side by something, I would have to multiply this side by something to maintain balance, and same for division. So we're going to look at this in a problem. So rewrite problem 1, question 1, part A, using variables and numbers. So we're going to let the rectangles equal x and the boxes equal 1. So I have 3 x's plus 6 equal to 1, 2, 3, 3 by 5, so 15 little boxes. So describe how the strategy we use to determine what balanced one rectangle can apply. So the first thing we did was we subtracted 6 from the pan balance. Well, that would be what we do algebraically too. And then the second step is we divide it by 3, and that's what we're doing here. So we get x is 3. Now it says substitute the value of x back into the original equation. So I'm going back into this. 3x plus 6 equals 15, and I'm going to put a 3 in place of x. So 3 times 3, order of operations, is 9. And when I add these two, 15 equals 15. So we do show that it balances. So what we did is we just solved a 2-step. So describe the order of operations we used in the original equation. So the first thing we did was we subtracted 6 to both sides, and then we divided both sides by 3. So that was what we did up in step A. Compare the way you solved the equation to the order of operations in the original equation. When I solved this, and I substituted in the 3, the first thing I did in order of operations is I multiplied by 3. And then the second thing I did was I added the 6. So you will see that solving equations, we do the opposite of what we do when we follow order of operations, and we do it in the reverse order. So first we multiplied by 3, last we added 6. So first we're going to do the opposite of this, subtract 6, and do the opposite of this, divide by 3. So we're solving opposite in the reverse order. So when we undo operations, it's often simpler to undo them in the reverse of the order of operations. So that's what we just said, opposite in the reverse order. In other words, the operation that came last in the original should be undone first. So write a sentence to describe how to apply inverse operations to solve each. So first thing I'm going to do is I'm going to add 15 to both sides of my equation. So I get 4x equals 76. Second thing I'm going to do is divide both sides by 4. Divide by 4, divide by 4, x equals 19. I can always verify, which it asks me to, by putting 19 back in. So I have 4 times 19 minus 15 equals 61. Okay, 19 times 4 is 76 minus 15, so I'm going to check that. I do get 61 equals 61, so I know for sure that's correct. Okay, I can do that again here. So the first thing I'm going to undo is this piece. So I'm going to subtract 2 to both sides. Minus 2 here, minus 2 here. Remember, we're always trying to isolate our variable. So I get 7x equals 14. Now I'm going to divide by 7 to both sides. And I get x equals 2. Now I need to go back and verify. So I'm plugging it back in. So I'm going to do that over here. 2 plus 7 times 2. And hopefully I'm going to get 16. Order of operations, I multiply first. Then I add. So I know for sure that this is correct. Let's try one more problem. Here I'm first going to subtract 5 to both sides. So I get x halves equals 11. Now remember, this means x divided by 2. So I'm going to multiply by 2 over 1. But if I do that to one side, I have to do it to the other. So this simplifies to give me x equals 22. So now I'm going to check it. 5 plus 22 halves equals 16. Order of operations, I have to divide before I add. So 5 plus 11 equals 16. 16 equals 16, so I'm correct.